second programming challenge for chapter 5 is called the law of large numbers. So that is the expectation to try to find some those patterns if you have a larger and larger number. So if you got time, please read this background. So it's described as about the expectation. So expectation is a discrete random variables is equivalent of the average or mean that we learned about in chapter 3. So when we consider the six-sided die, the expected value is every side have the equally the probability, so which is the 1/6. Then we add all of them with these values. Then we get this expectation result for six-side die is 3.5. And according to the law of large number, if we keep increase the numbers of the rolling, we can check what are the difference expectation we can get. So the average number is not kept as this 3.5 because 3.5 is the ideal number. So you can see if you roll 100 times, it's 3.39. Then gradually, when the number is increased to a huge number, then it's quite close to the 3.5. So our challenge for this practice is try to write a program to make this evaluate or to prove this law of large number. So let's create our part here. So first is make 0, 5, 0, 3 is number 2 is the law of large number. So let's starting from scratch. So the purpose, so prove the law of large number. So we first let's finish the calculation of those. So we have our the six-side dice. So we need to create our the initial the expectation. So let's starting from the mean parts. So we put is the expected value. Finally, it should be 3.5. And what we will do is let's print this first. Then is we see when we have this rolling number increase, whether we are approaching to this 3.5. So it's expected value. So that is very easy. Just use this format printing. So format expected value. So let's run here. So we got this one. So that is our first line. Then is we have our trial. So we give those different numbers. Then let's make it our average. Average value. So let me put this to our empty row, the list. Then it's for trial. In the scope is in our list. So 100,000, 10,000. So maybe let's create another. Is the trial value, trial number equal to, let's put this to to our variable. So then we can adjust that later on. 100,000, 500,000, or maybe it's yeah. Let's just keep on that. So trial in trial number. Then we have this. What we will do is we will try to roll our dice. So we need our roll the function. So but we anyway will get our average result from this. We call this roll and we transfer the trial. We need to transfer this IAL. And we will have our average result dot append with average. So we have this. This just prepared. Later on, we will do the plotting. So then we have this one. So we need to every time is we need to put this here. So the trial. And the trial with trial average. This we gave 1. And then we see here trial and average. So that is done for our current the code. And we will finish our function. So def the row with our number trials. So we have this one. What we will return? So return is the those probability. And then this we need to use our random number. So let's import random. And then when we have these numbers of the trials, let's have first is row is the empty. Then is for we create a for loop for this range on in our transferred this this number. Then we will have these rows. Rows is append. The result is we need is random dot random rand int, so 16. And then we are making our list of code rows. What we will return? Just we don't need to create another variable. We just return the total rows result divided by number of trial. Then that will be our average parts. So here is double L. So that is, let me save that. It's already working for now. So we can see here, every time you get the different kind of the things because that is a random number. But the approaching for this there's a trend you can see here. So if we want to visualize that, let's import mat this dot py plot splt. So what we will do is we have our two lists already. So let's do this plt plot. So one is this expected average. We should put trial number first as x and average as y. So let's make that simple. Is just put no label now. So let's show first. So you can see here is first when it's 0 or is let me make that 100. It's a 3.4 and this decrease, and this is 100. This is 10,000 and approaching to here. So if I make that emo the customize. Let's go to here is plotting. Looks like it's okay. So plt.x value. Let's give our x value is our trial, and the plt y value label. Sorry. So here is label and is the trial average. So let's see, run this to have a look. So we have our x and y. So and let's make this to another thing. So now we only have this 6. So let's make that in more the smooth one. So let me copy this for a second. Is plotting. So actually on the first is we already plot. So let me put that 2. And for first one, let's rename this to 1. Yeah. Anyway, it's on. You remember is on. You may lost. I hope it's you're not. But if you come to this GitHub, you just see a list of those code. But as I mentioned in earlier, the videos is actually in my this mind map. I suggest you to download the free plan and install that. And on the every section already finished, I have put the this code name, the program name, file name with this rocket icon. So link to the specific the parts. So which means is you may get those the program mapping to the each topic I have already mentioned. So for example, here, then you can reach this subchapter, then you can back to my video list to find the demo video. So that is a way is I try to keep our linkage so that you don't lost too much. So let's go to the tool. So we have two less the sample, I should say. So let's give our sample also our range. So let's see, here is our range is from 1 to maybe 10,000. Then if I have that is let's now make these things. So you can see here that is now is quite smooth, and but printing that is just a tool. So let me see. So is our I need to create a range. So let's starting from smaller. So yeah, you can see here. Now this range is from 1 to the 100, starting from the 5, and then gradually they have approaching to something. So, but if I disable this print, so I think we don't need this print, but let's expect that that can be the slower. I put this 1,000 times. Let's that to calculate. I will post that, and once it's coming, I will show you. Okay, I actually it's wait quite a long time, and even is during this time waiting as I finish my dinner. So now finally is get this picture. So now you can see. So we take time to calculate to 100,000 this situation. So you can see it's up and running, up and down, up and down, up and down. But finally, the trend you can see clearly is approaching to 3.5. So that is our the. I think it's we can see that is approved. So I will save this to GitHub to here over number 5, and this we what's the number? So large number. So just save like this, and I will close this. And I leave this code here, but I will change this to 100 back. So that if you can run it, it will quickly give this result. But you can see here, try to make the pattern of this one. So then if I run this again, so every time you get different pattern, but that looks is quite a big difference within 100. But you see, if we make that 1,000 times more, then that will be, or I think it's 10,000 times more. I did is you will see that's definitely go to 3.5. So, but here is already around 3.5. So that is the way is we have a test through this two code is verify law of large number. So I hope is you can test from your own, and you can wait a long time to get the similar these pictures like I put here for your reference. And I will change this number. So then it's 05032. So now this number is linking to our code now. So thanks for your watching and also the patient. For next video, we go to the how many toes before you run out of memory. So that may be another the time consuming, but we will see what that challenge means. See you in the next video. Bye for now.